and then see how that goes. Okay, so the first thing I want to talk about is the idea of this WPI. So sometime last year, the second quarter, the last quarter of last year, yeah, 2021, the NUC and NGREN and FUTO introduced an online sponsored institute project. This project was actually hosted by Worcester Polytechnic Institute, actually a private research institute in US, Massachusetts. So our university participated fully in the phase 1 to phase 3 of this particular online institute project, with various leaders, handling different, segments of the program. So the program actually was spearheaded by a former DVC R&D, Professor Bidan Nasion, and Dr. Charles, if you are close, if you are free, you can chat up DVC R&D to join. I've sent to Professor Gloria so that we can move at the same wavelength. So, so the VC appointed the R&D Vice Chancellor, Dr. Professor Bid, to spearhead the project. Professor Gloria was actually the administrator, and then I was able to work with Professor Achumba, who was actually the team lead of this whole project. Incidentally, before I, spearheaded and coordinated certain aspects of the program. Eventually, Dr. Anyogu was here. Anyogu was handling the online software virtual tools labs. I coordinated the WPI and FUTO exchange engagement, as well as handling the pedagogy delivery section. Dr. Achumba handled the education for industry. Dr. Sebanis handled the online instructional design, pedagogy, and faculty support. Dr. Laz was in charge of the student support, faculty, and then he was part of the course delivery. Now, these team leads, participated in isolated, work group projects, and then participated in the training with the experts from WPI. And the areas covered, like I mentioned earlier on, is actually pedagogy, faculty support, online software, virtual tools labs, student, institutional and faculty, online education for industry, and then online course delivery. The objective, actually, the idea here was to build strong capacity among FUTO staff to develop online programs and develop student support with the existing university infrastructure and faculty during the COVID-19 and eventually post-COVID-19. So this was the idea, and the university paid about $5,000 for our university to participate in this program. Likewise, many other universities in Nigeria. So at the end of that program, there were several presentations, engagements and all that, and the FUTO took part. And I'm sure because of our satisfactory performance, we were included in the second phase of the project, which is called the Africa Pandemic Engineering Program. So this phase 2 is actually a program that involved the use of faculties from WPI to work with African institutional partners like FUTO, UNN, and several other universities in Nigeria. The idea in the pandemic engineering was to develop a 10-week online training program that is related to pandemic engineering, covering areas like 3D printing, medical robotics, ventilator design and assembly, open source resuscitator and ventilators, both the assembled and unassembled, components. The idea was to engage in what we call reverse engineering and adapt it to local conditions based on supply chain resources. Why supply lasts? During the COVID-19, we understood that there was a massive, supply chain disruption. So the idea here was to use reverse engineering to improvise and create interventions that will help us to solve and meet the needs of our local environment. So that's the idea behind this pandemic engineering. So about 10-week module was actually slated. Incidentally, this happened when the ASU strike and several issues were really at peak. And so our university did not actively participate, especially those of the uh, team leads. But we were able to get the gist of what the whole program was all about. And then I followed up intensely because I know that our university, haven't gotten the approval to be included. Somebody have to just follow up, otherwise we miss out from the largesse. And so that led to our university receiving some of the equipment that our DVC mentioned some time ago. So, but I'll talk about that shortly. So actually the program of interest in the pandemic engineering spans through week 1 to week 10. That's actually Fusion 360 for design of most of the systems, design of 3D printing and topology, nursing robotics and 3D printed components, telenursing and affordable nursing robots, robot assistant long ultrasound, medical robotics for remote surgery, medical robotics and then laser, ventilator design and assembly, ventilator design, and then assembly. That's part 1 and part 2. And then finally, the affordable nursing robot demonstration. Some of these modules were actually coupled in WPI lab, and they were delivered virtually so that the participants can look at what has been done and then start thinking of the re-engineering concept. So what are the deliverables? The deliverable to our university is to intensify advocacy on STEM training relating to pandemic engineering. We are to reach out to local hospitals to assess their needs. Some of the hospitals around us we're supposed to visit them, check out their needs and see how we can use this knowledge to support their engagement. Now, the other one is to produce and donate PPEs to local hospitals where possible and permissible. Then work with regulatory agencies to adhere to local safety standards. Then share results with other African institutions. Outcomes of what we've done, are we supposed to participate and share our findings with other institutions and see areas of commonalities and then progress. Then continue to innovate with the equipment designs, reach out to local manufacturers for expanded supply chain. Remember, the idea is to bridge the supply chain constraints and then see how we can solve the local problems within our environment. Then finally, to continually engage in annual educational outreach opportunities like workshops, conferences, and all that. These are some of the things we're supposed to benefit from this engagement. So our benefit here is to derive novel templates for building engineering prototypes. Joint research exchange programs between FUTO and WPI team, especially in STEM-related fields, not just mechatronics or electrical, but any STEM-related field can benefit biomedical, civil, mechanical, ICT, information, all the disciplines within the STEM fields supposed to participate. So we're supposed to engage and produce joint high impact factor publication and conference outcomes from this engagement, and then engage our postgraduate students in the area of mentorship for PhD, masters, and all that, and then support our lab development and strengthen capacity within our schools. These are some of the benefits I saw from the program. So the action sought actually when the engagement was going on was to quickly accept this proposal from WPI, especially the pandemic engineering, and then encourage the management to pay for the shipping cost. Because our university participated in the first phase and we did well, we were included as beneficiaries of the supplies of this equipment. And then what that entailed was that we are not paying anything, and eventually our university received that donation because of our participation. The only thing now is that our university will have to pay just for the shipping of this equipment down here in Nigeria, but the equipment was given to us as a donation because of our engagement in the pandemic engineering and the online institute program. So this equipment will be useful for staff student training as well as lab support for accreditation exercise. That's one of the things I saw. And then re-engaging our online training program for staff and students in view of COVID-19 and post-COVID-19. And then a redesign of roadmap for engagement and impact assessment. So these are actually the actions sought. But interestingly, our DVC-R&D proactively actually have secured the the equipment that was sent to us. You saw on the platform, he mentioned that he's taking delivery of this equipment. So this is really commendable, and we want to appreciate him for that proactive disposition to get this equipment. So the next phase will be to engage with the equipment and see how we can make useful benefits from this equipment. So before I go into the component breakdown, I would like to check if there are questions. Otherwise, I will show pictures of what was shipped and the assembly tips before I now go into the breakdown. Hello.
Hello.
Yes. Hello, are we still together? Can you still hear me?
Yes, good evening,
Yes.
Doctor. I think you can
Yes,
go
I
on.
hear you.
Okay, thank you very much. Please, I want you to respond so that I know if I'm only talking to myself.
You're talking to all of us, Steve.
Okay, thank you very much. So, so far so good. Do we have questions? Because I want to move straight to the breakdown. I expect all the faculties to actually participate because I know this will benefit every one of the faculty represented. Especially now we'll have this prototype in our university. So if there are questions, I would like to, respond, and then we can move on to the breakdown of what was shipped to FUTO, and then you can see how it can benefit us, and come up with deliberation on how we can develop a roadmap that will benefit everyone. Thank you.
Hello. Can you hear me?
Yes. Yes.
Yes.
All right. Thank you, everybody. I want to just quickly ask clarification on the cost of the shipment. What is it like? Yes.
Okay, like I said, this equipment were delivered based on our previous participation. So it's more like an incentive. Remember we made presentation and we did very well, our university and I think FUTO Kure. So, and then we followed up. That was why we eventually, FUTO was included in the donation. And I believe that these donations were coming from the vendors that produce this equipment. So the shipping costs actually wasn't much. Some of the parts, some of the bundles were $300, some $350, some. So at the end of the day, I'm not sure it's up to $3,000. It's not up to that. And then DVC actually have taken delivery. So my job ended when I was told that this thing I've gotten to university, and the next thing, DVC called me and told me that he received a call to pick these things and then follow up. So most of the expenses, I think the university, they're already taking charge of that. Maybe by the time we'll do the final presentation, VC will get clear picture, and then I'm sure at that level they can close out. So the cost, I'm not sure it's more than $3,000 US. I mean the shipping cost with UPS down to Nigeria, but the equipment donation was actually given to us based on our participation.
Okay, yes, thank you for that.
Okay. So I don't know if there's any other question, even on the online institute part. That part we are trying to close out before the last administration, closed out, so to speak. Our DVC R&D then mentioned to me that the VC wanted us to develop our smart boards the smart board we have in our university, the complaint was that the department and the faculties, they weren't using this equipment. So before we could go into full online engagement, this equipment, these smart boards, ought to be in active operation before we can organize maybe a workshop that will help people to engage, using the module from the WPI. But I think towards the end of the administration, that's when they are doing the handover. We couldn't follow up. So that template is still there, but I'm expecting that all the team leads can come up with a collective position, and so that we can, advise the university to see how they can take advantage and then close out conclusively on that first part, the online training institute, because we had about 7 modules, like I mentioned before: pedagogy, instruction, lab, software, and all that, especially for online engagement. So that potential is still lying. We have not exhausted it. It's still there. And then the pandemic engineering is on board. So these are some of the things we have on board, and I think we can take collective decisions on the way forward. Okay. So I don't know if there's any other question before I proceed, please.
Please, Dr. Kennedy. I think we close out on the second leg of that training before the pandemic started. I think so.
You mean the online training institutes?
Yes, we completed it. We did.
No, I mean, yeah, there are 2 parts to that program. If you recall vividly,
we
the
completed first and second.
No, just
It
get my
was the
point.
3rd one we registered for, but some of us didn't continue.
Okay, look at my point. My point is that there are 2 parts. The first part was the trainer engagement with WPI. Then the other part was translation into our university. That part, we didn't do anything on it. That's the point I'm making. The university have not benefited from that engagement. That's the point I'm making. But for the other component, I think we relatively completed all the modules, relatively completed for those that were consistent, just like Dr. Charles observed. That's my thinking.
Hello, can I say something? Good evening, everyone.
Good evening, Doc.
Good evening.
Thank you, sir. I recall that there was a document that was produced marshalling out strategies and the kind of plan for bringing down what we did in part 1 to fruition in part 2 and going on to part 3 like we have now. Dr. Ken, you remember that there were some documents that team leads produced and submitted. Can we still trace them? Because the roadmap or the plan for going forward, I think we made some of them in those documents. Because like you said, yes, university has not really benefited because we've not translated those trainings we had to practice in the university. And that was the ultimate, and I think still remains the ultimate objective of the entire program. Sure. See the university imbibe that tradition that WPI is bringing. So I feel that if we get those documents, we should be able to see how to restart again. They might be dusty, but we can shake off the dust and then straighten up some things and know how else to begin, how next to begin.
Okay. Thank you very much. Why there was a statement the DVC R&D made on the WhatsApp platform when some of our colleagues were saying that we're on ASU strike, we shouldn't do anything. Yeah, actually we are far behind. We are lagging behind because at the point when I was chasing some people, they say they don't have data, they cannot join. So many, So at the point I was nearly discouraged, but my focus was to make sure that at least we have all the things in our university, even if people did not participate, somehow we can find a way and raise the rates. Actually, what happened was that at the end of that first phase, the DVC R&D then requested that we come up with a training template, which I'm going to share probably on that platform, especially for the team leads, covering those areas, because the agreement was that we should start with some of our general courses and then take it online, like all those, what do you call it, GST, and all those
Foundational
general
courses.
courses. Beautiful. That was what I think we collectively agreed, that we should customize the training in such a way that we move it online. And then once we scale and make some considerable progress, we can now begin to see how we can integrate other courses, as well as integrating with FUTO online learning management system. Alliance FUTO had an online, what they call learning management system from ICT, which eventually we were trying to see how we can get the vendors so that they can integrate with us, and then we can, benefit from the whole thing. But that didn't happen because the administration, finished, and then that was the end. So those documents, I think they are still around. I will source for the ones available, and then the ones the team leads did themselves, we can share these things, and then re-energize ourselves, because I know the energy went so low and people went to sleep.
Yeah.
So the team leads can come up with what they have, and then the ones I think we gathered, I will be able to still share them, and then we can dust them up and see how we can create a position for the university, because if the university did not benefit from that $5,000, for me, it's not really fair, So I think that is possible if we agree here, because it is actually this group that have the sole mandate to come up with a blueprint that a university can look at and then begin to implement as much as possible. So if we agree, we can gather all those documents, and then I share the one I have, the ones the team leads, the ones they can, they have access to. And then the timetable, there was a timetable the DVC R&D asked us to produce them. I think Dr. Madi was involved in that engagement. I can't remember again. So we'll just put those things together and see how we can, push it. The online thing is still active and still relevant. You can hear our VC still talking about online engagement, which means I think the management still have strong disposition towards online engagement. So if we can do that, I think it will benefit both our students and our colleagues, and then we can scale and improve. So that is what I have to say on that. So our position is that all the team leads here that have their document can push what they have to our group. The ones that I think I was able to gather, I will still push them to the WhatsApp group, and then we'll look at it and see what we can, how we can harmonize it, and then maybe share our views with our DVC around the, and if he approves, that will be one of the things we present to the management VC for upward implementation, and so that's my thinking.
That's fine by me.
Okay, so let me just quickly highlight what was shipped in the pandemic engineering, and then we can close out on the remaining stuff. So I proceed. Let me share that quickly. In the pandemic engineering, okay, so one of the research professor in mechanical and biomedical engineering. Sorry, I hope you can see my screen, please.
It's coming up.
Can you see my screen now?
Yes.
Yes.
Okay. Oh, okay. So the pandemic engineering, one of the things that what do you call it? The components that were shipped. This is a document that just gave a kind of synopsis of what was shipped and the assembly tips. So you can see here, this is the shipment structure, kind of. So you can see that these things were packed in cartons. These are the modules, you know, in carton. I think we received like 3 pairs or 6 pairs. I can't remember, but something like that. But they are modularized. It comes with the like a CKD. These are the electronic modules, you know, that we're going to couple together and then engage the system's operation. So these are the modules. This was in the lab when they were coupling it at the beginning, you know. This is their lab. This is the guy here is Obafemi, the research professor that was helping to assemble this thing. So these are the things they have. There are 2 assembled working ventilators assembled, the BVM and the airway component, the power adapter and 12 power supply. 1 ventilator kit with electronics and mechanical parts. So 1 assembled, 1 not assembled, so that it can help people to understand what the whole thing looks like. So 2 working assembled ventilators. This is the complete parts. The parts were numbered. For the unassembled one, the parts were numbered to allow plug and play kind of you know, deployment. So the assembled one and the unassembled one, the unassembled one had the different parts. I think they were labeled so that as we pick out the parts, we'll know exactly what to fit in. So it's relatively simple to couple, you know, looking at the way they, you know, labeled it. So on the 2 boxes, these are the items in the 2 boxes. These are the electronic components for the integration. So this is how the components, you know, integration looks like. So if we get the panel, we'll get the parts. So it's just like, you know, you have used some of the kits toys that have different discrete components. Pull the components, couple, rivets, you know, and like that until you get the complete system. So the entire casing actually have been labeled so that we can actually couple them together. So the same thing goes for the assembly, all the parts, you know. So we'll follow this assembly part, and that's why if you check the WhatsApp group, I was able to send a repository, a cloud-owned repository, where, you know, some of the materials and even the ones many universities, what they have done, because the idea is that as we receive this thing, we'll take pictures, we'll keep on uploading our cloud folder so that other universities can look at what we've done. And, you know, the idea is just to share resources and see how we can get the system running. So this is the same way. So these are just the, so at the end of the day, we're able to have something like this. Yeah. Hello, can you still see my screen?
Yeah.
Yes.
Okay.
Yes.
Okay. 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 So this thing was designed in such a way that it allows for reverse engineering. You know, we can think of other creative ways of actually building this thing, because it's actually, the controllers were built on what they call open source hardware. So our folks can build their own firmware codes and then calibrate it and program it to behave in a very specific and unique ways. You know, so that's that. You can see the yellow labels that shows the way the integration is done, from the ID cables to the modules to the display unit and all that. So that's, we'll have the electronic parts, we'll have the mechanical parts, you know, and then we'll have the software part as well. So this is what it looks like in a typical lab, you know, has been demonstrated now with the mechanical parts. So this is the coupling. We are going to do all this. Those of us that are participating in this call, we're going to do all this. And then at the end of the day, these things were shipped inside these cartons, and then they were sent to our university. So this is what it looks like. Overall, the pandemic engineering ventilators, this is what it looks like. So let me stop sharing this particular slide and then go back to what we had before. Okay, so I hope you can still see my screen, please.
Yes.
Okay, so I've been able to show you what was shipped and the assembly tips, I shared in that document. So this is what the open source universal ventilator, this is what it actually looks like. By the time it's deployed and mounted to our oscilloscope, we can actually, this is what it looks like in a typical deployment scenario. There's a software part of this where we have to program and calibrate this system to function in very unique and special ways. So this is the array of what they call the prototyping and the casements for the different schools that this is were shipped. So some of these other ones are few documentation. Like they advised, the system is not intended for clinical use. It's actually for experimental prototype to engage our skills and then help our students to understand how some of these things works. And then of course we can help institutions that have their own ventilator equipment. We can help to reverse engineer or help them to improve what they have. But these ones are not meant for deployment in the hospital. It's for experimental prototype. So there are parameters to be adjusted. Parameters like the CO2 removal, the tidal volume, the FiO2, minute ventilation, respiratory rate, oxygenation, and all that. This happens via the software part of this system. So we're going to be needing people, our colleagues in biomedical, we're going to need you a whole lot. Our colleagues in the medical field, we're going to need them as well, because some of the calibrations and all that will be determined by uniformly accepted standard within these fields. I might not know much about them, or some of our people that will be doing this integration might not know more about them. So we need everyone to be available to make recommendations where necessary. So respiratory timing cycle, the inspiration, exhalation, these things will be calibrated, programmed, and then see how it works. So these are the volume assisted controls on the ventilator, the frequency, the tidal volume, the flow, and inspirational pulse. Data can be generated from this, which could lead to very reasonable publication. Because this is a very good test bed for experimental setups. So this is what it looks like in a typical experimental test bed. So this is BVM, this is the ventilator, and then this is the calibration threshold where you can look at what is going on. So I'm looking forward to we working together to see how we can achieve these test beds with what we already have. And then this is the setup again. And these are the calibration threshold. So so this is the casing again, and then the modules and the lights. So with all this, I'm going to share, I've already shared the folder, the cloud folder where we have all these repositories. I've actually shared this folder with us so that we will begin to look at this folder, look at this document, and then we'll begin to engage. Dr. Bono, I don't know if you're here. We worked on a ventilator some time ago. The previous ventilator that the previous, our former VC, I remember there's a ventilator we worked on some time ago that we used to demonstrate during the COVID-19. Some of those principles applies here. So Dr. Waji is here, Dr. Mbon is here, Ehujo is not here, and some other colleagues. All of us, we are all involved in this. We have to make this work because As they have shipped this thing in those cartons, they won't be there. We'll have to set those things up, and then maybe we can use it as a shared resource or something, and then see how we make use of it. So everything is here, and these are just pictures of what the whole thing looks like. This is software parts where we can do a lot of programming and some integration. So those of us that do programming, we're going to do some programming here, where we need to use some PuTTY terminals when we're going to be integrating with probably Ethernet router or switches and route and stuff like that. VS Code for writing codes on the visual interface. Like I said, this system is an open source platform, so it supports all manner of modifications with the existing source code. So this is the PuTTY interface where you do your connection and hardware integration. So some of this will not be when we're doing the coupling and integration. We'll be able to do all that. Many of the universities, people have been doing theirs, hosting their codes on GitHub. GitHub, some have been engaging in improvising and improving the codes already, adding software to Ethernet interface, modifying the motor speed, waveform generation, alarm sensing, calibration, and visualization. Some have been working on the hardware and all that. So we need to make our own contribution because many have been making theirs. So let me quickly share with you that particular folder where we have this. Okay, I shared this particular link with us on the WhatsApp group, and I think we can make use of it. I'm sure you can see my screen now. Can you see my screen?
We still see your screen, but it's loading.
Okay, once you finish loading, please let me know.
Yeah, we can.
Okay, so if you look at this screen, you will see that these are the contributing universities in Nigeria, and will I say West Africa, because I can see Ghana, University of Accra, Ghana, they have their folder, Mauritius, Niger, all the universities within the African continent. These are the ones that have succeeded in doing something. FUTO being a beneficiary, UNN, Uniport, Uniports have theirs, NUTM, Filtron, AUST, this African University, and all that. So these are the universities that have actually made some inroads so far. I think the NUTM have done quite a lot. Their folder is over 3.4 gigabytes of various contributions. So you have opportunity of opening these folders and looking at what is in the content, and then studying and then seeing exactly what contributions people have made with respect to reverse engineering of these ventilators. So we'll create our own folder here, FUTO folder, and then our teams will begin to add contributions. So first of all, the complete supply, we need to take pictures of every of those supply and then send the picture into our folder here, because we need to put up our own folder here. And then so right away, let me create FUTO folder, FUTO WPI team. So I've created our folder. Excuse me. Okay, sorry. I'll add it. I'll add it, and then I'll start loading content in it. So once our folder is here, WPI should be able to access it to know our progress. If we are doing well, we stand the chance of getting more equipment from the vendors. If we start doing well, we stand the chance of getting more equipment. Part of this pandemic engineering is what they call sustainable engineering, where they are supplying solar lanterns, water filters for engagement in rural communities to find out how, water purification and how environmental sustainability can be carried out in remote environment. So all this equipment will be useful, maybe as a collective or shared resource for accreditation and our individual research engagement. So I want to encourage everyone to see how they can, everyone will participate and see how we can scale with this opportunity given to us. So this is the folder for repository for all the universities, and I'm sure we can make good use of it. So the last folder I want to share is the folder for the resource pool, where all the materials and all the things we need actually we can actually access. So if you look at this under folder, I've shared this already on the WhatsApp. You can actually go through these folders and then see how we can learn one or two things and see how you can contribute moving forward. So finally, Dr. Mboni says he's been trying to connect. Okay. So I don't know if you have questions so far, because I want to summarize. My summary will be that DVC mentioned that now he has received all this equipment. They want to make formal presentation to the VC, and after that presentation, the team's supposed to start doing something, and then to see how we can scale, and then how we can make good use of these things to help our students and help ourselves. So far, so good. This is what we have in the onboarding section. Some person that will be asking, what is this whole thing all about? What I presented to you is what the whole thing is all about. If you do well, we'll get more equipment supply. And then we can actually even engage them for joint exchange programs, because they are really willing to support as much as possible. If that happens, I think it will be another good plus to us. So Dr. Kuma, Dr. Charles, and every other person on the call, I think we can close out on this now. So if you have questions, we can ask, and then let's take decision. DVC said by Friday, she will meet VC. I spoke with Professor Gloria. She told me that VC will be around throughout this week and the beginning of next week, so that those that want to make presentation or something can do that. After that, she might not be around. So maybe that's why DVC chose Friday. For those of our colleagues that's been around or that are around in our Owerri, please, you do well to try and join in that meeting. I'm actually away on a very serious engagement. Hello?
What time is fixed for that Friday?
DVC just mentioned that Friday is good. So I think it's a discussion that we'll have to engage him on that platform, so that we'll be in the same page, on the same page with him on that particular Friday. I think it shouldn't be more than anything less than 12 noon and above. So we can raise the discussion based on this presentation now. We can raise it on the platform to find out from him, or I can ask him. Any which way is okay. Since he's already on that platform, we can get the dates, the time. It's important we all participate, please.
I'll be there.
Okay. So Dr. Charles, Dr. Ike, Dr. Emma, And Dr. Chijere, I think, I don't know some other person on this call. Please pardon me if I don't mention your name. This is where
Just a
we are
minute.
now.
Just a minute before you close, Doc. Still on the action points. The first thing we need to do is to inform the DVC and let him fix the time for Friday. Then I believe that what we need to do that day is just to